So this section of Chapter 4 notes, we're going to be looking at doing some stoichiometry. So for this, you're probably going to need some kind of calculator to kind of follow along, and possibly a periodic table to kind of see where some of these numbers are coming from. So we are going to take these combustion type problems, and we are going to try to figure out, if we start with so much material, how much product can we make from this. So the first type of problem I'm going to show you is something called a gram to gram problem, and it's always going to be in the same format, so there really is not going to be much different here. But please remember that a balanced chemical equation is essentially your recipe, okay? So I need so many moles of this, so think of this as essentially your cups and trying to make some product. So we are going to be using a concept called the mole, okay? And 1 mole of any substance is equal to what we call its molar mass. And I'm going to abbreviate molar mass, capital M, capital M. So if we use the periodic table as our standard, we're going to look at essentially the atomic mass is going to essentially be equal to 1 mole. So if I have 1 mole of carbon, I have 12 grams of that. Again, that's our standard, is carbon. And we could use the periodic table kind of as our go-to for that. So oxygen is going to be another one that we need. That's 15.999. So 1 mole of oxygen is going to be equal to about 16 grams. And then if I have 1 mole of hydrogen, hydrogen has a mass of only 1. So I have 1 gram. So I need to convert all of these things, all grams, to moles, because this is 2 moles to 9 moles to 6 moles to 8 moles. So that is our standard that we go off of in chemistry. So what I'm going to do is I'm going to calculate the molar mass of C3H7, just one of those molecules. So if I add that up, okay, so the molar mass is going to be, I have 3 carbons, so it's 3 times 12. Plus I have a total of 8 hydrogens, so 8 times 1 gram. And I have 1 oxygen, so I have 1 times 16 grams. So that ends up being about 60 grams as the molar mass of 1 mole of that molecule. So I could take the individual atoms and add them together to get the overall mole. So the first thing I need to do is convert from grams to moles. And if you had chemistry before, we taught you how to do proportions. So what you're going to do is take the starting material, 82 C3H7OH, and you're going to say, how many moles is that? And what you're going to do is put the molar mass, which is 60 grams for every 1 mole. Okay, and then you find the number of moles. Then you take the balanced chemical equation and do what I call a mole-to-mole relationship. So if I have this many moles of C3H7OH, how many moles of H2O? So I have a recipe, so 2 cups to 8 cups. But as a chemist, we say 2 moles to 8 moles. So what I could do is over here, once I get the number of moles, and this will be the moles of C3H7OH, that is the X that I got here. How many moles of water will that be? Okay, so I know that for every 2 moles of C3H7OH, I get 8 moles of water. Okay. So once I get the number of moles of water, then all I got to do is convert the moles back to grams, because all of these are going to be what we call gram to gram problems, meaning you're starting with grams and you're going to grams. So I'm going to take the moles of water, and I'm going to see how many grams that's going to be of water. And I'm going to use the idea of the molar mass of water. Well, molar mass of water is, I have 16 grams, because if I have oxygen plus 2 from the hydrogen, I have a total of 18 grams for the molar mass. And my X comes out, once all of this is done, to be about 98 grams of water. Okay, so that's how you were taught first year chemistry. But what I also want to show you is a different way of doing these types of calculations. It's called dimensional analysis. And what you do is, instead of having all of this 3-step problem, is you put it all into one configuration. I'm going to show you that setup. So you're going to take what is given in the problem, and then next door to it, you're going to put a relationship. Okay, and I'm going to convert it to moles. So I'm going to put moles on the top, and whatever unit you're in is going to go on the bottom. That's going to be 60 grams because I have to cancel out the units, and I'll then be in moles of C3H7OH. Then I take the next proportion essentially, and I put the unit that I'm in of C3H7OH, and I put on top of that the moles of water. So I go back to the balanced chemical equation. So this is going to be the balanced chemical equation that I look at, and I see that I have a 2 in front of the C3H7OH compared to the 8. And again, we did this up here, but again, in order to cancel out, the unit that you're in goes on the bottom and the unit you want goes on the top. Then finally, I have 1 mole of water and I need to convert it to grams, so I take the molar mass of water and put it on top. So then this cancels this and I'm left with grams of water. And you get exactly the same answer and you get less of a rounding issue as you go. I do not care how you do these problems, but I'm just kind of showing you a different way going forward, so you can maybe use that. So the only other type of problem we're going to do in this class is I am going to convert to liters. So there is some gas being produced. Carbon dioxide is a gas, and sometimes the water is as well. And there is a relationship having to do with gases only. So please write down gases only. So every gas, if it is at a standard temperature, always gets 22.4 liters. So this problem, again, I'm starting with the same balanced equation and 82 grams of the product of the starting material. I want to know how many liters of CO2. So this is just kind of expanding your ideas on how to do some stoichiometry problems. So I'm going to set this up like I did before with my dimensional analysis. So I'm going to convert it to moles first. So again, the molar mass we've already converted, and that's why I picked this problem, okay? Then I have to use the balanced chemical equation, but this time I'm comparing C3H7 to CO2. So I have 2 moles of C3H7OH, but I have 6 moles of CO2, okay? So that is different because, again, it is a different product. All right, so then finally, this is the point at which it is different than the last part. So the last part was the molar mass part. This one, the nice thing is, this will always be the same. Every mole of any gas, and it's only going to be CO2 that we do, you're always going to end up with 22.4 liters. So if I didn't cover this before, mathematically what you have to do is you could just multiply everything on top and then divide by the bottom, or you could take 82 divided by 60 and then multiply by 6, divide by 2, and then multiply by 22.4. It all works out in the same. You're going to get around 92 liters as your answer.